This job finished while I was putting the rest of the video together. 200 support tickets went through the Anthropic API, processed 200, errors reported 0. If this process had conventional exit code, it would be 0 as well. Estimated cost on the strip is 26 cents. The run took just over 8 minutes. 25,501 input token, 12,170 output tokens. Those are live Sonnet 4.5 numbers, not a fixture. The failure mode I care about in this video is the one that survives code review. The loop completed, the UI painted every tile finished, and if you were on a call, you would have no reason to stay on this page. Green on this page means Claude returned the response we could store as a row. Every one of the 200 rows has OK true. The priority on that row is a separate question, and it is the one that matters in front of the payment outage. This video is the first video in the series called Claude Jobs that survive production. Across the 5 videos, I keep one patch pipeline, the same tickets, the same repo, and the same product service. Each episode changes one layer of that system. The product on screen is Triage, a teaching app for this series. The fictional workspace is the payments team that dumps support ticket into an internal classifier and expect Claude to set priority, category, and whether anyone should be paged. People wire this kind of things up, watch it look healthy for a week, and then stop reading the outputs. In this episode, the pipeline is a queue of tickets on disk, stored into data/tickets.json, a Python for a loop as a worker, and a function iteration run in version 1 naive /engine.py, a call to Claude for each ticket inside process1 function, and the result file that the UI reads back through. Tracing, a real job queue, evals, and a memory of previous incidents come in later videos. Starting here makes those layers earn their place. The legend at the top of the board is a state machine the live job understands. Page is waiting, the ticket is still in the list, Lime is classifying, the HTTP call is in flight, green is done, we wrote a row, red is missed, and it only appears when I press Audit Gold, which hits the function Audit in the app.js. Let's have a quick overview about the architecture of this version. The browser is a static board. That code lives in the web modules. In my project, it's called web under the v1 naive module. We have the index.html, style.css, and app.js. All module calls go through a fast API process in the server module, server.py. When the page loads, the function load in the app.js asks for the API tickets and API meta, which are the functions, tickets, and meta in server.py. When you open a tile, the function open drawer in app.js asks for the API tickets/ID, which is the function ticket in server.py. When you press run patch, the function run patch in app.js posts API/run, which calls the function run in server.py and reads the server sent event stream so the tiles can move from waiting to classifying to done without pooling. Fast API is a thin shell. The function run starts a background thread named worker. That thread iterates the function iteration run in the engine module, inside the engine.py module, and pushes events onto a queue. The nested function stream forwards those events to the browser. Audit Gold is a different endpoint, and the function gold audit in server.py is the one that will be called when the endpoint API audit called, which calls in return the function audit in engine.py. The engine module is the job, actually. So iterate_run calls load tickets to read the tickets.json, walks the list, and for each ticket, the function process1 builds a prompt, calls the Anthropic messages API, and parse model JSON turn the reply into an object. When the list is exhausted, write outputs writes 2 files under the output. The first one is a v1_results.jsonl for the rows and v1_summary.json for the counters you see in the headers. The CLI module run.py is the same generator. Inside it, the function main consumes the iteration run. The data plane look related. Tickets.json is the input, load tickets reads. Gold.json is a set of labels for 47 tickets we designed to break under this architecture. Load gold can open that file. Process 1 never calls load gold. Results and summary are what the board treats as truth after a run. The function audit joins result to gold after the fact. Claude sits outside the process boundary, so we can see underscore ticket underscore context in engine.py sends a truncated ticket body and the constant prompt, and we get back priority, category, should escalate, and one line summary. The request carries the prefix of the body. It carries no gold label and no incident memory. One request, one JSON object, then the next ticket. That's the entire version 1 architecture. A synchronous loop with a model in the middle, a UI that mirrors the loop, and the label file the loop never loads. So let's see what happens to a single ticket. Here is a pass for one ticket, because the 200 tickets run is just this pass 200 times. The ticket is a JSON object with an ID, subject, customer, and a body that can be a few hundred characters or a few thousands. The function iter_run in engine.py yields an item start event, so run patch in app.js can paint that tile lime. Then iter_run calls process 1. Inside process 1 function, the helper underscore ticket underscore context slices the body to the constant body limit, which is 800 character. That slice is the only body text that enters prompt. Process 1 then calls client.messages.create on the Anthropic SDK. The messages API returns. Parse model underscore JSON strips a markdown fence if one is there and loads the JSON. We construct result row that includes priority, category, escalate, summary, token counts, latency, and a boolean name truncated if the original body was longer than 800 characters. Then we set OK to true and iter_run yields an item event. The UI paints the tile green and pumps processed. If anything in the try block raises, a parse failure, an API error, a timeout, process 1 calls default OK, which writes priority P3, category unknown, escalate false, and an empty summary, an OK true with swallowed true. The board still goes green, the summary still counts 0 errors. This take never hit the except pass. 200 calls, 200 OK true, 0 swallowed exception. The silent failure on this board is a classification, not a crash we papered over. When the loop ends, iter_run assigns errors in the summary. That value is written in rather than reduced from the rows. Write output persisted. I'm defining the operation metric as a loop completed. The function main in run.py does the same thing in text. It prints OK for every index, including the rows we will later mark missed. Cost is a signal here. Tokens increment because the SDK returns usage, so the dollar figure moves. The error figure stays at 0 because we never ask whether the classification matches the ticket. The batch is already over, so the job did run. iter_run in engine.py already walked all 200 tickets, already wrote version 1 result.jsonl, errors equal to 0. The green tiles are that story. Nothing on this board has been checked against a correct answer yet. Gold is an answer key. It lives in gold.json in the data folder. We wrote it by hand for 47 tickets we know should page someone. The live job never opens that file. Process 1 classifies a ticket and moves on. It does not ask was I right or not. Audit gold is the second step I added for this video. You press the button. After success is already on screen, the function audit in app.js is just a click. It calls the API audit endpoint on the server. The function gold edit in server.py receives the call and hands it to the function audit in engine.py. Load gold reads the answer key. Load results read what Claude already stored. And then we have is wrong function, which puts the two rows next to each other. A ticket is wrong when any of these is true. Claude's priority does not match the answer key. The answer key says page on call and we stored it, don't escalate. The answer key says this is an outage and we stored some other category. So something differ from our source of truth that Claude didn't respond as we expected. If those matches, the tile says green. If they don't, the tile turns to red. So now let's read the banner. Gold says 35 tickets are wrong. The job still says 0 errors. Both numbers are true. 0 errors means the loop finished. 35 means the answers were bad. Here is where the 35 comes from. We planted 47 traps. 15 tickets hide a payment outage after a character 800. Claude only saw no rush. All 15 are red. 10 tickets are basically empty. Subject says see screenshot, body is the file name. A human would escalate those for a look. Claude closed them as B3. All 10 are red. 10 tickets say don't page anyone in the first 800 character, and the real outage is below that. All 10 are red. 12 tickets try to trick Claude into writing a paragraph instead of JSON. Claude ignored the trick, returned billing JSON, and those 12 stayed green. The red paint does not change Claude's answer. For example, the ticket 10,000 is still B3 in the result file. We only ask question the worker skipped. The banner also shows a fake customer email from complaint.txt. Jake says the job finished and Twitter told them checkout was down. He writes 47, that's the angry version of the story. The measured number on this run is 35. So this is the bug the rest of this series is about. The process finished, the answers were wrong. No error fired because queue or the loop never compared Claude to the answer key to the single source of truth that we have currently. So let's take one ticket and look into it deeper. So for this ticket, we can see that the subject is doing real product work against us. It says this is a quick question about the dashboard and that is not urgent. A human skimming a queue would deprioritize that. Claude agreed, priority P3 category bug should escalate false. The one sentence summary it stored is non-urgent dashboard question with no clear issue described. The row has OK true and truncated true. Body length 3,324 characters. We sent only 800. Sent to Claude is the first 800 character of the body. It is polite filler. Hope you are having a good week. This is probably nothing. I did not want to bother the on-call rotation. The dashboard looks fine. Billing loads. They can still log in. No rush at all. The window even cuts mid-sentence on hi there. If you only had this window, B3 is a reasonable classification. Never sent is the remainder of the same field. Scroll to the tail. The line that matters is update. Payment API is returning HTTP 500 for every checkout in US East 1. Customers cannot pay. Started about 20 minutes ago. Do not treat this as low priority. The outage never entered the context window. We cut the body before the request. We classified the prefix and we persisted that object as the ticket's outcome. Goal wanted B0, category outage, escalate true. We stored the opposite. The drawer could show this split while the tile was still green. So open drawer in app.js, fills, sent, and never sent from ticket detail in engine.py. That helper reconstructs the cut at read time from the original body. Truncation is on the row as data and it never moves the error counter. Let's have a very quick walkthrough through the code. So we have the function it run in the engine.py, which is a worker. It constructs the Anthropic client, calls load tickets, and yields a start event with the total and the model name from model name. For each ticket, it yields item start, calls process1, accumulates tokens, and yields item. After the last ticket, it builds a summary. It calls write output and calls finish capture and yields done. The function run in the server.py start that generator on the background thread named worker and streams the event through stream to the browser. The board is subscriber. Run batch in app.js is the client. Classification happens in engine.py. The function main in run.py consumes the same generator and prints a line per item. The last print is process 200 error 0 exit 0. The CLI uses the same summary and has no miss list. The browser is how we watch that contract. So look at the summary construction inside iterate run. Errors is the integer 0, written in rather than reduced from the rows. Success means we got to the end of the list. That is useful metric for a cron that must finish. For a classifier that can leave an outage unpaged. It is the wrong headline number. The body limit is a constant at the top of the engine.py. We have 800 there. I picked a number that's easy to say and easy to see. In a real service, this is usually a token budget, a last end messages heuristics, or truncated log line. The shape is the same. You decide what the model is allowed to see, and then you forget that the decision happened. The function ticket_ticket context slices the body and interpolated that slice into the constant prompt. Process 1 then sends the context prompt to client messages.create. The prompt asks for priority, category, escalate, and one sentence summary, JSON only. That schema is fine for the prefix. It can only classify what is in sent. 25 tickets in this batch were longer than 800 characters. All 25s are in the miss set. That is every truncated B0 and every contradiction trap. The cut is a whole bug for those rows. There is no log statement that the original length was 3000 and we sent 800. The teaching drawer reconstructs sent and never sent from the original ticket at read time. Inside ticket detail. Production code that only persisted the prompt we sent would leave you with the confident B3 and no tail to open later. A context builder is part of the architecture. In this version, it is ticket context _ ticket context, a slice with no ranking and no record. The fix later in the series is still a budget. The difference is we will treat the cut as a decision we can inspect. On the happy path, process 1 calls parse model JSON, fills the rows and sets OK to true. If the original body was longer than the limit, truncated is true. We leave that flag unused for control flow. A truncated outage is still successful classification. That was the case for the ticket 10,000. On any exceptions, the except in process 1 calls default OK. That helper writes a closed ticket, B3, unknown category, do not escalate, empty summary, OK true, swallow true. A parse error or an API error becomes the same shape as we looked at this and it was nothing. This run did not need the helper, 0 exceptions. The 35 misses are all parsed, built, and wrong. Catching exception is still in process 1 because that is how the worker is written. Mapping every catch onto successful low priority clause is how you produce a successful batch whose contents are garbage. If you catch, the row operators has to stay failed until a human or a retry says otherwise. This worker does the opposite. This file is answer key 47 tickets. We already know what the right priority is. The job that classified the tickets never opens the file. There is a function that can read it. The function that talks to Claude never calls it. That is why the board went green first. Checking the answer is a button I pressed after the job is already done. 15 of these tickets hide the payment outage after the character 800. All 15 missed. 10 are empty screenshot tickets. All 10 missed. 10 say do not page and the outage is below the cut. 12 try to make Claude stop returning JSON. Claude ignored that and those 12 also stayed green. So the answer key has 47 traps. Gold marked 35 wrong. The cut is what actually failed. The job still reported 0 errors because it never compared itself to this file. So here is a problem I can't solve in this video. The 35 misses are sitting in the board. I can only see them because I pressed button after the job finished. While the job was running, every one of those tiles was green. There is no trace of the prompt, there is no snapshot of what Claude saw. If I go back to the ticket 80, I can tell you what we sent except by reconstructing it from the original body. The process finished, the answers were wrong, I found out after. Next video, I put a trace on every Claude call, same ticket, same loop, each call writes down the prompt, the reply, the tokens, and the latency while the job is still running. Then these 35 do not wait for audit gold. They show up in seconds. The repo is in the description. Part 2, I traced every Claude call. The message showed up while the job was still running. If this helped, like the video, share it, and subscribe. I will keep posting AI development videos. We will find the interesting features together and how to actually use the tools. Thanks for watching.